Hello everyone, in this video we're gonna do a NumPy pandas project, a project that looks at network traffic anomaly detection. We're gonna do four things. We're gonna detect anomalies based on the packet size, based on the protocol used, and also we're gonna calculate the traffic volume per each and every IP address. And lastly, we are going to use the Z-score to do some anomaly detection. So right now, this is my network traffic data. So this is our source IP address. This is our target IP address. This is the packet size. This is the protocol used. We have TCP, UDP, and ICMP protocols. And this is the timestamp and also the size, the bytes sent from one IP address to another. So for now, we need to look at the anomalies based on packet size. So let's get started. So to do that, we need, let me first run this cell. All right. So we need to convert the list of lists into a pandas data frame. If you notice, I've already imported NumPy and pandas right here. So we just need to convert this one to a pandas data frame. All right, so our columns, so we have source IP, we have destination IP, we have packet size, we have protocol, timestamp, and lastly, byte sent. All right, so let me just input it real quick. Source IP, destination IP or target IP. We have protocol, timestamp. We have byte sent. What else do we have there? All right, that's all we have. All right. So our data frame, is equals to data, which is this data right here. Then we're gonna match it with the columns. Columns is equals to columns. Perfect. We also need to convert the packet size column to numeric. So I will just comment size to numeric. So our data frame, packet size is equals to PD to numeric. We need the packet size. Yep. Looks good to me. Let's do, we also want to set threshold. So packet size threshold, let's say 1,000. Now we need to filter based on threshold. So anomalous traffic is equals to our data frame. When it's greater than our threshold. All right, and now after this, all we need to do is to print there and less traffic. All right, let's see if there's any type of error. I'll run it. Condense. All right, columns. All righty. What if I do this? More space. Perfect. Let me run it. There you go. It went through. All right. So basically, what I did is I merged the columns first. So we have our source IP, destination IP, packet size, the protocol, and the timestamp and the byte sent there. Now we also converted the packet size to numeric and also set the threshold size to 1000. And now we are comparing the packet size, this one, this column, if it's greater than the threshold that we set. And we now print anything that is greater than 1000. So we discovered that line 4, 6, 7, 8, 9, 10, 11, 12 is greater than the threshold. So this will be this will be the rows of data and the IP addresses that are associated with anomaly size of packets that are sent. All right, let's move on to the second one, which is detecting anomalies based on the unusual protocols. Alrighty, I'm going to change this onto Markdown and run it. So how can we do it? Let's look at the code. All right, let's go ahead and detect anomalies based on the unusual protocols. Alrighty, detecting. So protocol counts. Protocol. Yeah, perfect. We also need to set threshold for an unusual protocol. Protocol. Unusual protocols is equals to protocol counts if they are, let's say, less than 3. Alrighty. Then we need to just print this unusual protocol. We just copy it. Let me go through one more time. Protocol counts, protocol counts. All right, let's run it. So our ICMP, which is this one, it is less than 3. So we have it has this IP address is sending to has been communicating the destination IP address within a different protocol. So and we set it to, if it's more than 3 is usual, it's less than 3 is unusual. So the result this says that it gives us this ICMP protocol, and it communicated to us twice. So if you go back to our data set, we have ICMP right here and another right here. All right, let's do the third one. Traffic volume based on IP address. Markdown and run. Alrighty. So we're gonna do three things here. We want to first, of course, you see this byte cent. Right, this one more time. So we're gonna look at the byte cent. Want to convert it byte cent. Where is it now? We wanna convert this one is a string. We wanna convert it to numeric, so we can easily manipulate it. And also we also need to calculate the traffic volume per each and every IP address, then per each and every source IP address, then print the results. So let's get started. All right. So we start with the data frame. Now we're looking at byte cent. Is equals to PD to want it to be numeric. Then our byte cent here, numeric to numeric. Our data frame. Then we want byte cent again. And our errors. Alrighty, then we also want to do traffic per IP address. So now we are looking at the source IP address. So it will be data frame dot when I want to group by the source IP, and also want to look at the byte cent. So byte cent, and we want to sum it up. We want to sum them up. And lastly, we just want to print traffic per IP. Let me just browse through to see and run it. Alrighty. So let me look at it one more time and see what's happening. Let me make it more visible. All right. So traffic volume per IP address. So these are source IP address. We want to look at the summed traffic volume. So we see this 192.168.01. It would 9,000 gig, 728 bytes. So we're kind of summing up every total bytes per each and every IP address. So we see that this is communicating more with our destination IPs, and this is the lowest. So we can visualize this differently, but that's how you do it. And let's do anomaly detection. Via the Cisco markdown and run it. Alrighty. So to do this now, we need to import stats. So traffic z scores equals stats.z score instead of z score traffic IP. Do it this way. We also need to define the threshold of anomaly. So IPs is equals to traffic. Uh-huh. We might need to use the absolute ABS traffic when it's greater than 3. And we want just to print out the anomalous IPs. Let's run and see. Let me expand it a little bit more and run it. All right, let me take a look at it and see.